Hey guys, welcome to a new video. In today's video we're going to look at a Leetcode problem, and the problem's name is calculate delayed arrival time. So in this question we are given a positive integer called arrival time denoting the arrival time of a train in hours, and we are also given another positive integer delayed time denoting the amount of hours delayed. And after calculating the new time, depending on how many hours the train is delayed by, you have to return it as a 24-hour format. So here in this case you can see the arrival time is 15 and the delayed time is 5. It has to arrive at 15, which is 3 p.m. but it is delayed by 5 hours, so it will be arriving at 8 p.m. So 15 plus 5 is equal to 20. 20 stands for 8. But in 24-hour format we return 20 as output. So here in this case 13 denotes 1 p.m. and if it is delayed by 11 hours it will arrive at 12 a.m. midnight. 12 a.m. in a 24-hour format is 24, but in the clock it is displayed as 0, so you return 0 as the output. Now let's take a look how this question can be solved. So let's see how this problem can be solved. I've taken the same example given to us. This is the arrival time and this is the delay time. And now we need to find the new arrival time based upon the delay time added to the arrival time. And we need to return the output in 24-hour format. The input is also given in 24-hour format, so this is 3 p.m. and this is 5 hours. So if you add 5 hours to 3 p.m. it is 8 p.m. So how do you get 8 p.m.? You added 15 plus 5, which is giving you 20. So 8 p.m. in 24-hour format is 20. So you have the range that the output should be between 0 to 24, right? And here in this case it is between the range 0 to 24. So 20 will be returned as output. Now let's take a new example. So the input is 13, which in 12-hour format is 1 p.m. and it is delayed by 12 hours. So if you add 12 hours to 1 p.m. you get 1 a.m. the next day. You got this by 13 plus 12, which is equal to 25. But you can't return 25 because it is not in the 24-hour format. The output should be between 0 to 24. So you have to reduce it using the modulus operator. So if the new time is greater than or equal to 24, then we have to use the modulus operator and divide it by 24. The remainder will be the new arrival time. And in the false case, it means that new time is less than 24, so you return the new time as it is, like we did in the prior example. So here the new time was 25 mod 24, which will give you 1. So that is our expected output, right? So this is 1 a.m. the next day. Now let's implement these steps in a Java program. Coming to the function given to us, this is the function name and these are the two integers, new arrival time and delayed time. So I created a variable called arrival, which is initially 0, and I'm calculating the arrival time after adding delayed time to the new arrival time. This new arrival time variable name is a bit confusing, but this is the input given to us. So when you add delayed time to the new arrival time, you get our arrival time, which is the new arrival time actually. So but I named it arrival. And now we have to convert this into 24-hour format. So I'm checking if the arrival time's value is greater than or equal to 24. Then I'm using the modulus operator to reduce the range of the arrival time between 0 and 24. So if it is greater than or equal to 24, it will be adjusted to the 24-hour format when you modulo it with 24. If it is less than 24, you return arrival time as it is, else you update it and then return the arrival time after updation. Now let's run this code. The test cases are running. Let's submit the code. And the solution has been accepted. So the time complexity of this approach is O of 1 constant time, and the space complexity is also O of 1. That's it guys, thank you for watching and I'll see you in the next video.